So today we are going to learn how to rearrange an array element by sign. So let us try to understand what is the problem state here is we should need to rearrange the array elements by the sign. So let us try to understand what is rearranging array elements by sign. That means, so we have given an array here that is 3, 1, 2, minus 2, minus 5, 2, and minus 4. What you should need to do here is, first, let's try to understand what is rearrange. That means you need to put all of these like so. Here you have given an array which contains positives and negatives, right? Which contains positive and negatives, and the array size will be n, and it contains n by 2 positive elements and it contains n by 2 negative elements, right? It contains n by 2 positive elements and it contains n by 2 negative elements. That means here 3, 1, 2. There are three positive elements and there are 2, minus 4, minus 2, minus 5, minus 4, three negative elements, because we have given an array which contains equal positive and negative elements. Once what we need to do is we should need to rearrange the elements by sign. So what is meant by sign? Sign means we should need to arrange the elements by alternatively. How we should need to arrange? We should arrange this as one should need to be positive, one should need to be negative. First positive, then negative. First positive, then negative. We should need to arrange in this way. What happened after rearranging the given array? Then it will be look like, so here 3 is positive and minus 2 is negative. Here 1 is positive, minus 5 is negative. Here 2 is positive and it is negative, right? So here the array seems like here 1 is positive, 1 is negative, positive, negative, positive, negative. So in this way we should need to arrange the array using this, right? Using this property. So this is rearranging array elements by sign. So let us try to discuss the brute force solution for this. Okay, so let's try to, sorry, bad. Let's write the brute force solution for this. As a brute force solution, here we need to understand one thing, that is, here there are, if I say 0, if I do the indexing 0, 1, 2, 3, 4, and 5, here 0 indexing element is positive. So okay, I'll write this better. I write this 0, 1, 2, 3, 4, 5. Here 0, here the first index we have got the positive element, and for the second index we have got 0 index, we have got the positive element, and here the second index we have got the positive element, and here the fourth we have got the positive element, and remaining was the negative. This is the negative element, this is the negative element, right? We need to understand this. So this is important for doing the brute force solution. So can I start the brute force solution? So in brute force solution, what I'm going to do is I'm going to take a positive array. So I'm going to take a positive array. I say positive array. So in this positive array, I'm going to store all of the positive elements, and I take a negative array. In this negative array, I'm going to store the all negative elements. And I say I'll start the iteration from here, third one. And I say 3 is a positive element, so I'll put it into the positive array. Yes. Then I move. 1 is a positive element. I'll put it into the positive array, and then I move. So minus 2 is a negative element, so I'm going to put it into the negative array. Say negative minus 2. Then I move. Minus 5 is a negative element, so I'm going to put it into the negative array. Then I move. 2 is my positive element, so I'm going to put it into the positive array. That is 2. Then I move. Here minus 4 is my negative element, so I'm going to put it into the negative array. So once the iteration has completed, I've got the positive elements and I've got the negative elements. So how So okay, here we should need to understand this. This positive array take the size of n by 2 and this negative array take the size of n by 2. And here positives is equals to negatives. This is how the brute force solution is going to work, because there are brute force works only if there are all positives and if there are only negatives. If they're both equal, then it's going to work. That's a brute force solution. So I say we have got the positive elements and we got the negative elements. So let's try to do the indexing here. So I say according to this. So according to this, we say this is this positive element will be, first element will be at the 0th index, and this is it will be at the second index, and this will be at the 4th index. And if there would be some other array, some other element that is going to take the sixth place, right? Okay. So I say this is B, this will be initially 0, 1, 2. This is B, normal indexing. So 0 index element will be at 0 and first index element will be at 2 and 2 index element will be at 4th index. Okay. So let's try to code this thing and understand more. I say I'll take a for loop that is I equals to 0 and I say I is less than n by 2 because the size of we're using two arrays that is positive and negative, so we're using the size that is n by 2 for arranging both positives and negatives. Then I say, oh, I should need to put the all positives. I should need to put the first positive and then the negative. For that I'll say array of 2 into I is equals to positive of I. What is this 2 into I? So this is going to tell my positive index where should I have to put the positive elements, like this 0, like this 0 will be placed at the 0th index and 1 will be placed at the second index and second element will be placed at the 4th index. So this is going to tell my all positives where I should need to put the positive elements, right? Okay, let's do for the negative elements. That I say this is same as like that 2 into I plus 1. Plus 1 is going to give my, is going to put my negative elements. So because 2 into I was, because 2 into I is going to give my positive index, and if 2 into I plus 1 is going to give my negative index. So this is how it works. So this is how it works. This is the brute force solution, and I hope you get it. So let's try to analyze the time complexity here. Then I say time complexity here will be big O of n, big O of n plus n by 2. So big O of n for traversing the array and n by 2 for arranging the elements at the positive, uh, for this, putting this positive elements and putting this for arranging the positive and the negative elements alternatively. So we say n by 2 and divided by 2. So this is the time complexity, and then the space complexity will be like big O of n, absolutely, because it should need to return the ans no, so it is using some extra space, that is, so big O of n for traversing the array, segregating the positives and negatives, right? So space complexity is big O of n. So big O, for the time complexity, big O of n is for traversing the array and segregating the positive and negatives. So this is the brute force solution, and I say, so using this we can put the positives. So using this we can put the positives at sorry, so this using this we can put the positive elements at even indexes, that is even indices, or you can say even indices. This is used for putting positive elements at even indices, right? Okay, this is used for putting positives in the even indices. You see, this is the even index 0, 2, 4. These are the even indices, and for the negative indices, that is 1, 3, 5. These are the negative numbers. So this is used for negative elements placed at odd indices. Negative elements that will be placed at the odd indices like 1, 3, and 5. This is how it works. This is the brute force solution. So now let us try to do the optimal solution for this. So let's try to do the optimal solution. So in I know one thing for sure. All the positive, I know one thing for sure, that is all the positive elements are stored at or placed at even indices, at even index, right? All the positive elements are stored placed at even indexes, and all the negative elements are stored at the odd indexes. So this is for sure. I know this is for sure. We all knew this. So what I'm going to do is I'll take an answer array. So I'm going to take an answer array. I say answer array. Let me zoom this. Okay. I take an answer array and I say, okay, this is my answer array. I'll write the indexes. So let me drop this 1 second. I say answer array. That'll be like this. Yeah, okay. I say 0, 1. I'll write the index first. 0, 1, 2, 3, 4, and 5. Okay. So what I'm going to do is I'll I'll take a positive variable, that is positive. I say positive. I know one thing for sure, that 0 is a even indices. So positive will be at even indices, and if I move the positive, then it will go here at the next index, that is 2. Next positive indices is 2, and then next positive indices, that is 4. So this is how the positive is going to travel. Okay, and I say this is my negative index. This is my negative and this is my positive. So I'll start iterating the array. I'll write with another pen for better one. I say this is the positive and I say this is the negative. Right. Okay. This is good. So I'll go to the first element. Hey 3, you're a positive. So you're a positive number. So I'll say you go and assign. So you can take our first place, which is a positive element. I say, hey 3, you're a positive element. So I say you can take our first place, which is a positive, which is assigned for positive numbers. So in that way, 3 will be here. Then I'll move. This is 1. When 3 is assigned at the positive, when 3 is assigned at the positive indices, then I'm going to put the positive indices at the next. I'm going to put this positive in the next positive index. That is, that is 2, right? It will come here. So I'll go to the, and then I move to the next one. So here we have 1, which is a positive element. Then I see you can go to our second index, which is assigned for positive elements, and 1 will come here and 1 will come here. Then I move this positive indices, this positive to the fourth index, which is assigned for positives. Then I'll move. I see -2. -2, you're the negative. So minus 2 is the negative. Then I say you can take the place which is allotted for the negative elements, is allotted for the negative elements, which is assigned for the negative elements. Then here the minus 2 will come here. Once the minus 2 is assigned to its negative place, then I say here 3, then the mm, negative moves to the other negative index, that is 3, right? Okay, then I'll move this. So minus 5, so minus 5 need to go to the minus 5 is assigned to the current negative index, that is 3. So minus 5 will go here. Then I move, then this negative index is moved to the other negative index, that is 5. That is 5. Then I move, it will be here 2. 2 is a positive index. Then I say positive, you have the positive index. Then you should have to assign at the positive index, that is 4, and it is go here. Then the positive index go here. Then I move here the negative minus 4. So it is assigned at the negative index, that is 5 minus 4. Once the negative index is assigned, then we'll go here. So this is how we can optimize this. So this is how it's going to be work, right? Okay, so let us try to analyze the time complexity for this. Since we are doing a single pass here, we are using one pass to rearrange the elements, right? We're using the one pass. So the time complexity that is comes here is time complexity is big O of n, and the space complexity is big O of n, because we should need to return the answer, right? We should need to return the answer. For that, the time space complexity will be big O of n. The time complexity will be big O of n for the optimal solution. So right now we are seeing a similar kind of a problem to the previous one. So this is, I can say this is the variant 2. I say this is the variant 2 for the problem. This is the same problem. This is a variant 2, because what they have stating here is so problem have all positives and negatives, but they are not sure about that. Is they're saying that the problem have positives and negatives, but they are not saying that positives are equal to negatives, like n by 2 for positives and n by 2 is negatives. They are not stating this thing, right? Okay, and they say if any positives and negatives are left. So once we have arranged the positive, negative, once we have arranged the positive, negative, and positive and negative, if there will be any kind of positives, only positives will left, we need to put them at the last of the array, right? Okay, they have stated this at the left. Put at the left. We should need to put them at the left and add them with add them at the end without altering the order. They're saying we should need to add them at the end and without altering the order, which we should not have to alter the order, right? Okay, so by this problem I have we have understanding, that is we have understand, that is if positive elements are not equal to negative elements. I have two cases in this case. First case is positive elements would be greater than negative elements, and negative elements would be greater than the positive elements, right? We have these two cases which need to put in mind according to the problem. So how the answer will going to be look like? I say answer will be look like, what I do here is I'll arrange first the positive in the alternating alternate order, but by using sign. I say my first element will be positive and my second element will be negative. And my first element will be positive, my second element will be negative. So here what they are stating is we should not have to change this order. The order will be like 2, 4 and 1 in this way. The order should be like in this way. This is the order 2, 4, 1. This is the order they have stated that. So we should not have to change the order. Then how my answer array will be look like if I say answer value will be look like this. So first I put my positive element, then I put my negative element, then I put my positive element, then I put my negative element, and whatever the elements that are left, what elements that we left here is, here we left the 4 and 1, right? This is the condition for positives is greater than negatives. Here the positives are greater than negatives, right? So what I'm going to do is we're going to put these both at the end of the array. They have told you to do this. Yes. So for this, what we're going to do is, I say we'll just try to do this using the code. Let me explain this using the code. So okay, did we can do the optimal solution for this? So we can't do the optimal solution for this because we can't do this because optimal solution runs in the fact that is all positives is equals to the all negatives. But here the condition is different because positives are not equal to the negatives. So we can't use the optimal solution. So what we should need to do is we should need to jump into the brute force solution. So for that what I'm going to do here is, let me erase this quickly. Yeah, okay. So let us try to do this. So what I'm going to do here is I'm going to take in brute force solution, what we have done, we have take a positive array, right? We have take a positive array and we have take a negative array. So similar we are going to do here. So I'm going to take a positive array and I'm going to take a negative array. So first what I'm going to do is I'm going to put my all positive numbers here. So this is negative number -1. So it's going to put in my negative array. Then I'll move. This is my positive. So I'm going to put in the positive array. Then I move. This is my positive. Then I'm going to put in the positive array. Then I move. This is my positive. Then I'm going to put in the positive array. Then I move. This is my negative. So I'm going to put it into the negative array. Then I move. This is my positive. Then I'm going to put it in the positive array. So this is how we have got all of the positive and negatives. Here, positives are greater than the negatives. So we should need to use this case. We have two cases. We know that positive is greater than negative and negative is greater than positives. But here in this case, positives are greater than negatives, right? Okay, we are going to use this case. For that, I say what we need to do here is we'll code this thing. I say for I equals to 0, I will be. So before that, I just wanted to say one thing, that how the array is going to look like is for the first 4 elements, that would be 2, -1 and 3 and -3. So this is how the 4 elements is going to be arranged, right? So here there are positive elements are 2 and the negative elements are 2. So we have got the 4 elements here, right? So total we have got the 4 elements here. So for that we are writing the code to arrange the positive equals negatives. We should need to arrange this first, then we'll jump into the and this. Okay, I'll say for I equals to 0 and I say I will be less than 2. Because why I less than 2? Because there are smaller negative elements that are smaller less than 2, right? That's why using 2, right? That's why using 2. Let's do, then I say, as we know, we should need to arrange all of the positives first. For that, I say array of, I into 2 is equals to all positive elements, because this is going to put my um, positive positives in the, this is going to positives are placed at the even index. So this is used to put my positives at, this is used for place the positives at the even index, right? Okay. I say array of I into 2 plus 1. Plus 1 is going to put my negative indexes. This is used for put my negative indexes at the odd places. So this is for, so this this is for putting the uh, first four elements of positives and negatives, right? This is used for putting all positives and negatives. Okay. Once we have done this, how the array is going to look is, once we have done this, the array look like 2 minus 1 3 minus 3, and the remaining elements that are left is 4 comma 1. This is the leftover elements. So let's try to write to put this leftover elements, like leftover elements, right? Let us write here here this. So we are sure for thing, one thing is, we have we've put the four elements here, four elements, right? That is 0 1 2 3. So where should I need to put the leftover elements? Leftover elements should need to put from this index, that is 4. That's why I take an index value. That's why I initialize an index value, that is index is equals to 4. Index is equals to 4. Then I say I'll write a loop. That is for loop I equals to 2. Why I say I equals to 2? Because we should need to, why did I put I equals to 2? So we should need to start putting the leftover elements from the positive index, that is 2. Here we knew this 0 1 and 2. We should need to put these leftover elements. So this elements, this index is going to be from here, that is 2. So we're going to put these leftover elements from the second index, that is for I is equals to 2. I have to get it. Then I say I is less than positive dot size. Why I say positive dot size? Because here we have, here, because here we have more positive elements. That's why I say positive dot size, right? Okay, positive dot size. So okay, and what I'm gonna do is, then what I'll say is array of this index, the current index 4, put all of my positives, all of my remaining positives, that is 4 comma 1, put them and increment index while putting the left, here 4 elements are arranged, and while putting this, and the index that is going to start from this is the fourth index, which need to place this 4 value here, 4 element here, and then at the fifth index which need to put the one positive integer. For that I should increment, right? I should increment to 4 to 5. That's why I say index plus plus. So that's how it's going to be work. So let us try to analyze the time complexity for this. I say time complexity. Here the time complexity will be like big O of n plus big O of min of positives and negatives plus big O of leftover elements. say big O of leftover elements, right? Okay, let's try to see this carefully. Uh, See this carefully. Here we have two cases. Here we have the minimum case, and here we have the maximum one, that is max. For the minimum case, if in the minimum case, if all the elements, if all the given elements are all positives, or if all the given elements are negatives, or if all the, or if or if in the array, or if in the given array there are no positive elements and there is no negative elements, then I say, then my time complexity will be look like big O of 0 plus the leftover elements, will be big O of n, for the leftover elements. What will be the my max? Max, as we know, this max is going to work for the positive. Max means positives is equals to negatives. That means I can say here this is n by 2 and n by 2. Then my time complexity will be like n big O of n by 2 plus big O of 0, because there are no leftover elements, because positives is equal to negatives, right? Okay, for this is for the max one, and you get it. So let us try to understand this whole thing. This whole thing is going to take the worst time complexity. So this whole thing is going to take the worst time complexity. That would be like, so this is for first iteration, this is for the first iteration, and I say big O of n plus big O of n, because this whole thing is going to take the worst time complexity of big O of n. Okay, then I say, then the time complexity will be look like this. This is for the first iteration, big O of n, and the time complexity will be big O of 2n. And what will be the space complexity? This space complexity will be big O of n. So this is how we find this space complexity and the time complexity. This is how it's used to look. This is really simple. I hope you guys understand for the variant 2. And what if it is going to give you the negative is greater than positives? It's similar. We just need to reverse what I have done here. We just need to reverse this thing. We just need to reverse. You should need to put here the negative one, negative. Then you should need to put the negative dot positive. Here we should need to put the negatives. Okay, I hope you get it. You can do this.